Making things in space is challenging. Jamie covered a lot of stuff, so I'm not going to kind of rehash what he said. So my presentation will be short and sweet, but I just want to kind of give you guys like a bit of an overview about some of the stuff that I've learned in doing things for space. So it says zero gravity flight in space. I'm kind of conflating at this point because they're both pretty bizarre environments, and I think it's kind of fun to think about like space stuff while you're working on the zero gravity flight, because that's the goal, right? Is to actually get stuff into space and have all those fun experiences. So so my talk is entitled "Making Things for Space is Challenging." A little bit about me. I won't waste your time showing you videos. I did that in the last class, but later on, if you want, I can show you videos of some cool dinosaur robots that I made. And I also invented the 3D pen, which is a fun toy. So I kind of basically a hardware hacker type of guy, mad scientist. So come to me with your mad scientist questions. Space hardware is the art of making things protoflight. This was a term that one of the people at the Blue Origin group that we work with introduced me to, and I love the term. So protoflight is an engineering project that has never been tested. It was finished the night before launch, and it absolutely has to work perfectly the first time, or else embarrassing amounts of money and time are going up in smoke. No pressure. So there's a couple of pictures here of some pretty complicated looking hardware, and it had to work the first time, and it was kind of untested. So that's, for me, that's one of the funnest challenges is coming up with ideas and getting them to the point where the first time you use them in their natural environment, like they will work. It's neat. It's kind of fun. Live demos often fail. This is zoomed in a really strange way. Oh, here we go. Live demos often fail. There we go. Live demos often fail. One of the properties of making complex systems for the first time is that they will need to be well tested in the short amount of time that you probably have. This means you should be testing as you design and build. Do not wait until it's all together to see if it works. You want to test sub-assemblies as early and as thoroughly as you can. A lot of times what I will do is I'll work on a few different parts of the project in parallel, and I will have kind of things that are critical path. And I'll say, like, there's some component that there's like 8 of in your design, and that has to work. So work on that and get it working perfectly before you move on to the rest of the design, because the design choices you make early on can impact things later on. So you don't want to be going backwards in your decision tree because something didn't work earlier on. For example, a first project involved getting some simple motorized latches to work. That would hold some experiments for launch, and then release them on command once the thing was launched. I made a single latch, one of these single latches for testing, put it in a wooden box, and me and Ariel went down the street and literally like kicked it around the street and like dropped it off a bridge to test it, just giving it high shock loads, that kind of thing. It was a really fun experiment. It was a great, nice sunny day. We had a great time. And we tested it, and it got an intuitive sense of how reliable this thing was to shock loads, which was very helpful for kind of continuing. Vendors and contractors. Salespeople are often not the ones you want to talk to. Sales engineers are better, but they're not always better. And if you hire a contractor, this is like zoomed in a weird way. I really apologize here. Okay. If you hire a contractor, vet them and make sure they would be a qualified employee. That's sort of common sense, I guess. But if you're working with vendors, you want to make sure that they can do the job, that things will go smoothly. Sensors. Jamie covered a lot of this, so I don't need to really get into it. But sensors have their quirks. Ultrasonics tend to be bad with soft things. They're better with rigid, hard things. IMUs, which might use a lot in space things, are subject to aliasing with high vibration, that kind of thing. So you want to know the pitfalls of what you're doing. Magnetometers love finding metal, and you're in a giant metal tube. So these are the sorts of things that you have to kind of keep in the back of your head. Wiring, fewer conductors are better. Oftentimes, I found myself in places where I could have put a connector, just direct soldering, because it's a good hard solder joint is pretty reliable to vibration and shock. So sometimes you do things in a slightly different way for a high vibration or a stress environment than you would like in a terrestrial environment. So it's something to think about. Strain relief, everything. This is going on a crazy rocket. So you want to take your experiment and shake it around. If you see anything wiggling, screw it down, glue it down, strain relief it. You want to get everything to be really well secured. Wires that move are wires that break. A lot of space stuff has requirements in terms of wire sizes and insulation, so you want to be aware of that early on, so you're not having to rewire everything, with the regulation wire. So read all the manuals, like figure out what they require for all of these different components. One thing we ran into, for example, is they wanted Teflon coated wires and no PVC coatings, because PVC is flammable and you might be in a high oxygen environment in space. So they're careful about fires and things like that, obviously, in space environments. Wires are antenna, so be careful with those. Be careful with connectors, blah, blah. Okay, moving right along. Connectors, I'll fix this. There we go. Connectors, you want lock-in connectors. Don't use the kinds that just kind of push in and stay there. Well, the pins on your connector briefly disconnect under shock loads. One design that we did was, I don't know, is my camera working? I can't tell if you can see. Probably not, because I'm sharing. So, yeah. So one thing that we did, we had a part where there were two things. Oh yeah, thank you, Ariel. One thing we did was we had two things that had to be electrically connected and then released on command, and we didn't want that connection to be unreliable while they were stuck together. So we actually had a little spring pushing against the metal contact to help make the electrical connection. So we used the compliance in that spring to kind of take up some of the shock and vibration load. So those are the kind of tricks you can think about for connectors. And I would not use consumer grade connectors like USB ports and things, because like my phone never charges. Like those things tend to be kind of unreliable. Verify everything with a voltmeter. Voltage and current. Jamie kind of talked about some of this. Anything above 48 volts wants to kill you. DC feels like a hammer. AC feels like a jackhammer. It's fun. Anything above 1 amp wants to start a fire. Rapid switching can cause EMI. Too much current through a loopy wire can induce voltage, because you're basically making a transformer. Human flesh is conductive and will burn. So just be mindful of bare metal, open contacts, things like that. Miscellaneous, digital AD is better than analog AD, ADD, because it's just simpler. So I tend to gravitate to that. Use metric fasteners, you heathen. Metric is good. Avoid Phillips, because you can